I'm going to give a talk on some of the work that's been done on ETH2 execution and phase 2 execution over the last 10 months to a year-ish. And a lot of this work has been done by the Quilt team and a general perspective of what we have done during that time. So the Quilt team in particular, right now, we're a group of 4 people. Sam, Ansgar, Matt, Will. You've probably seen us present in different forums. And we've been collaborating with the EWASM team and the ETH2 research team on a lot of the work we've done over the past few bit. So I'm going to just do a quick overview of just like the phases, and I've shared these slides before, and then breeze through that, and then just talk about what's forward. So as you all know, phase 0, this is where everyone's attention is at right now, and this is coming out pretty soon. And it's very, very exciting. And you can think of this as the master system. This is what manages the overhead consensus of the shards and everything else and connects the system together. Phase 1 would be coming shortly after that. And this is where we have 64 data shards. So in this case, if you have a certain amount of allocation of bytes per block, you can multiply that by 64. And now you have this reliable data availability layer that can be accessed, and this can drastically enhance ETH1. And this works really well for, these are terms that have been thrown out a lot lately, which are optimistic rollup, ZK rollups, systems like that, and provide a lot of scalability, which is really, really exciting. So phase 1 gives us this data layer that we can seep into. And then we have phase 1.5. Danny Ryan wrote a really good research post on ETH Research around this, and Mikhail has been doing some interesting write-ups on this as well. And phase 1.5 is where we marry ETH1 and ETH2 together. And so in phase 1, where we have those 64 data shards, we actually allocate one of those shards to be ETH1. And then we have execution of ETH1 on that shard. And now it has better access to the system. It has access to proper finality guarantees and everything else, and gets us a step forward on a full execution system. And so in this merge, one of the things is ETH1. There's significant effort being put on this right now. Becomes stateless, and this means if you're running a node, you no longer have to keep track of this large database of state to be able to validate, right? So now you will be able to just look at what we'll say are witnesses or the database that's provided with each block to guarantee that it's proper. And this is the major ETH1X effort. And for this merge to happen, this will be shipped within ETH1. And so this also massively enhances what ETH1 is today. And then so we have phase 2, and this is expanded execution. And phase 2 is a really big open greenfield space. And so I want to talk about, like, Vitalik about a year ago put a couple proposals towards execution environments. I'll talk a little bit about that for a moment, and then move quickly into some other interesting things that are happening and that Quilt's been involved with. But within execution environments, one of the really valuable constructs of this is it keeps ETH2 as a core consensus light, almost pure layer without strong opinions. And one of the reasons why that's really cool is it can allow you to actually build multiple execution semantics on it. And so this has been talked about before. You could have something like an ETH1 system running on it, UTXO, something like Move Libra, other account models that are running on the same shard, and they're all talking to each other and communicating with each other. And one of the reasons why this is particularly appealing is one of the weights or loads on ETH1 is if you want to make changes to ETH1, let's say the transaction format, the way the account is structured, you typically have to go through a fairly intense governance process, EIP process. And this is also a political battle as well, as you have to navigate different client teams and making sure that client teams will also implement these updates. And so one of the things that execution environments did, which is very, very interesting, is it tries to leave that up to actually developers. Developers can deploy their own account models over the system, and then users could migrate their contracts between them. And so, in ETH1, if you have a transaction format and you want to add an extra field here or have a different encoding schema, then to update that, you have to fork it and you have to work with the different client teams. So this kind of describes some of the values and some of the protocol values, long-term value that it gives. And so over the last year, Quilt and also the EWASM team did a ton of research on this. We prototyped a bunch of EEs. We did major benchmarking. I did a Medium post that goes into some of the measurements that were there. We looked at ETH1 as an EE. We built truffle-like tooling to be able to launch EEs and figure out how that works. We did a simple, we even did a simple demo at DevCon showing an EE running on a Lighthouse phase one light system as well, which is an interesting prototype. We looked at other things. I won't get into this. This looks at changing some of the state rules that we work with in ETH1 today to make them a little bit more flexible. And this is something that we call static state access, and really interesting updates. And then how do we have EEs communicate with each other? How do we have them talk with each other? And so after Stanford, blockchain, and EthCC, Paris, we kind of all came together, and reflected different teams, Quilt as well. And one of the things that we're looking at is the phase 2 space being so wide open and so greenfield. There's a very ambitious plan and goal to build this system that really hasn't been tried before, and you don't see a lot of this happening on a lot of the other efforts or protocols. And so one of the things that we talked about is how do we reach that vision, but how do we do it in an iterative way, and how do we do it where we also maximize our synergy and focus on some of the big efforts right now, which is getting phase 0 out, getting phase 1.5 out. Making these major changes to ETH1 to support a stateless system as well. And then also, how do we do this in a way so we get this tangible process? How do we do this in a way as well that dApp developers have like a really good transition? So it's very ETH1 centric, and it bridges ETH1 in a strong way. So this is kind of the reflection and everything that had been discussed. And so there's basically two big efforts going on right now. So there's phase 1.5 efforts. A lot of people are working on that, specifically to execution in phase 2. The Quilt team right now is actually building as an early dive into execution environments, cross-EE communication, and answering a lot of these things. We're actually building an old concept into ETH1 called account abstraction, making some adjustments. This is getting us early data on how do you then begin to abstract the entire transaction layer, the entire state network, all these things which EEs and execution environments provide. And then there's also a work being done by the EWASM team, which is ETH1x64. So this also pushes an iterative data-driven concept of this first execution engine on ETH2. And ETH1x64 is where we take ETH1, we multiply it across all the 64 shards, and we figure out how does it talk to each other, how does it communicate with itself, what type of protocol functionality, what type of opcodes do we add to make that work. And this is a way that we can get tangible data right now on that, and we can get a prototype and get learnings from that, which may expand into an entirely new account model, or an upgraded account model from what we have on ETH1, as well as with the learnings of account abstraction. And if we expand to a new account model, we could have multiple account models operating in tandem, ETH1, maybe an upgraded one. And this is kind of an early vision of multiple environments, execution environments, or clients running. One other thing that I just like to mention that's interesting is execution sharding can always be dynamic and iterative. So for example, we already have data sharding with phase 1. So the data throughput is increased significantly, and this is quite powerful. With execution sharding, if there's always a path where you start off with 4 execution shards. If there's not if it's not extremely busy, or the transaction throughput isn't as high, then you can wait to begin dynamically adding additional shards and trying out different concepts as well. So there's always this kind of open space to be able to do that. Account abstraction, some interesting things. So this brings some of the core EE functionality to ETH1 in this phase 1.5 merger. And just to give like a brief update on what that is it introduces a new type of contract. And these contracts are self-sufficient. They can submit their own transactions, and they customize how they validate a transaction and how they validate those transaction formats. It also expands the capabilities of our mempool and kind of prepares us for some of the changes that we might need in the long term with ETH2 regarding stateless mining, static state access, some other concepts that we've been doing research on and exploring. So just some like immediate use cases that account abstraction would have, which is cool, is it allows onboarding steps for users to be skipped because a contract can pay for their gas fees. It brings new signature methods to ETH1, so you can now customize your transaction format, BLS, Stark verification, Schnorr, ECDSA. If you're an enterprise, this might be interesting to deal with NIST compliant. Also, it brings major privacy benefits for mixers, et cetera. Smart contract wallets now can submit their own transactions. Currently, you have to have a third or a second EOA account, and you have to provide gas from that account to even be able to interact with your smart contract wallet. This allows the smart contract wallet to use its balance to be able to do that. Also, it helps with state channel improvements. And then also rollups, what we've been talking about with phase 1.5 and this data availability layer. It helps get us a really cool framework for how rollups can communicate with each other, how you can exit liquidity between rollups and transfer these funds in a quicker, more elegant way. It provides cron job support. These are transactions that can stick and be rerun over time. And it gives us some progress towards ETH2 and phase 2. In general, and some of these things. And so just to recap, these are some of the efforts that are going on towards phase 2. I think phase 0 is the focus right now. So, and then phase 1 shortly after that, and then the merge. But I think it's good for people to understand that there is constant, tangible progress and work being done on what does like the long-term vision of ETH2 look like? What does execution look like in the long term? And I think we need to continue to keep our focus on that even whilst these first steps are being played out. Thank you. And if you have any questions, feel free to find me on Twitter. It's WJVILL, and I'll go ahead and post links to these slides as well. Thanks, everyone.